This is going on page 25 when we are done. So I have used the words points of inflection with you. I've thrown those words out at you a couple of times, but today we're actually going to talk more in depth about them and write them down and whatnot. So points of inflection, probably most likely new terminology for you this year. A point of inflection occurs when a function changes from concave up to concave down or vice versa. It's where the concavity changes, okay? And then it says at a point of inflection. So remember, words are very important. If you were at a place, you were at a single location, at a point. If you were over something, you were over an interval. Okay, so there's things that we do over an interval, and there's things that we do at a single x value. So this is a point. That's why it's at a point. The rate of change of a function changes from increasing to decreasing. So those two things, so the definition of it is it's where the concavity changes, but then we have it tied to rate of change with our fun chart. So let's write our fun chart out. Okay. And so with the U and the N there, that's not really a U and an N, those are my two concavities. So like where the concavity changes or where the rate of change goes from increasing to decreasing or vice versa. So in between these two, this is where your point of inflection is. So if you can at least remember that the point of inflection is where the concavity changes, so you know what happens right here, then you will also know what happens right here. Okay, just little pieces, you can kind of put it all together. All right, so then let's look at this graph in this first question here. So this is the graph of g of x. Use the graph of g to answer the following. Find any values of x where g has a point of inflection. All right, now, remember, we can't actually accurately find the point of inflection without calculus. So there on our notes and maybe even on your assignment, I might ask you where the point of inflection is, even without like an actual dot there for you to know for sure. And you may have to estimate it. Just don't stress out. Don't make it harder than it is. On an actual test or the AP exam, nobody's going to ask you that because we can't find it accurately. Here, we're just going to kind of estimate where it makes sense so we understand what's happening without them just telling us. But that's not something we can really, really find accurately. So if I look at this, I want to know where this has a point of inflection. So my function is concave up, then it turns to concave down, right? It's not always halfway in between. It depends on the function, but it looks like it kind of happens right there. Would you agree with that? And then we're concave down and we change to concave up. I would say it looks like it kind of happens right there. Plus those are at whole numbers for us right now, so we're good, right? And then that just remains concave up. So I think we have a point of inflection at x equals -1 and 1. Because the location is the x value. The value is the y value, right? And we're not interested in what that is. Okay, everybody good so far? All right. Now it says for each of the following intervals, determine if the rate of change of g is increasing or decreasing and explain your reasoning for each answer. Okay. So when I look from our first interval, and look, it says on the following intervals. So there's no question that this is an interval. I'm not trying to plot the point 3, 4. That makes no sense in this context, right? So from 3 to 4, right here, that's just this part of the graph. I want to know if my rate of change is increasing or decreasing. And then it says explain your reasoning for each answer using the features of the graph. So we have to make sure we talk about the things we can just look at the graph and know. The things we can look at the graph and know are in the first row. The things we deduce from that are in the second row, okay? So do we think from 3 to 4 that the rate of change is increasing or decreasing? Increasing. Then why? Because the function's concave up, okay? Not because my rate of change is getting bigger and bigger, which is not, that's a true statement, but that's not using my graph. You with me? So we have to say those things. Now, we also have to pay attention to how things are named and make sure our words are good. Right? What's this function's name? G, okay? Is your name Melissa? If I called you Melissa every day, would that bother you? That'd just be rude because I wouldn't know your name, right? But it would also be weird. But what if I called her Melissa and I called her Melissa and I called her Melissa and I even called him Melissa, right? And him Melissa and him Melissa. That would be insane, right? Every function is not F. Make sure you name them correctly. And if you're not naming them correctly and you're calling everything F, that's when I start calling you Melissa until you get your functions figured out, right? You have to name them correctly. That is part of our notation. It's important, right? Isn't it important to you for somebody to get your name right? We don't want to hurt their feelings either. So this guy's name is G, right? And so I'm just going to put a G up there because, yeah, it's said in here, but that way maybe I can get it done right that way as well. All right, so let's answer the question here. So the question is asking about the rate of change. So I can say rate of change of who? G. Rate of change of G is, and what do we decide it is? Increasing. Is the rate of change always increasing for G? No. So that's why we have to say the interval. I will say on 3 to 4. And I don't have to put the words the interval. Some of you did in your explanation of the quiz, and that's fine. There's absolutely nothing wrong with it. But that implies interval, so you don't have to use the word. But again, if you do, you're not wrong. So rate of change of G is increasing on 3 to 4. And that's answering the question, but then my explanation, because who? G is what? Concave up. Is G always concave up? No. Concave up on 3 to 4. So when you are writing this stuff out and you write out blah, blah, blah is increasing, then you ask yourself the same thing I'm asking you. Is it always increasing? If the answer is yes, you don't have to put an interval. If the answer is no, you make sure you put the interval. Okay, that can kind of help you not forget to write that stuff. Ask yourself the same questions I ask you. That's why I ask you those questions. All right, do y'all have any questions for me? We good so far? All right, so then let's look on the interval from -1 to 1. So I'm going from -1 to 1 right here. So what is happening with the function right there? Yes, but what's happening with the function itself? It is negative. It's concave down, good. The function is concave down, therefore the rate of change is decreasing, which is, again, was the right answer. But so rate of change is what we're actually looking at. Rate of change is decreasing because the function is concave down. So we're going to say rate of change of who? G is lowercase g. Yes, thank you. Remember, lowercase g, it matters. Okay. Rate of change of G is what? Decreasing on -1 to 1 because who? G is concave what? Down on -1 to 1. And because this was a graph and not a chart, we didn't have to say over equal length input value intervals. We didn't have to say all that stuff that we were having to write yesterday. Any questions at all? All right, then y'all do the third one. You can talk about it amongst yourselves to make sure we all agree. So yes, good job checking. I think it's increasing. We agree with that? Okay, so pretty much write just what you wrote in the first one, but make sure you use the correct intervals there. Always be careful when you're trying to model something else you wrote that you're actually using the right information for that part. Any questions at all? All right, so let's look back at the graph for just a second. Notice how on the first one, we had this little red segment right there, and that's really not all of the concave up part of the graph, which is fine. And this is like just here till the minimum. And so the function is concave up and decreasing. Here, the function's concave up and increasing. Here, the function's concave down, but it's increasing then decreasing. And I think when we had one where it had a section like that on one of the questions on the homework, some of y'all had some questions because it kind of just looked different. But when we're talking about the concavity, it can just be a piece of the concave up part, or it can be the whole concave part, whatever. It doesn't matter. It's just that I couldn't just answer like, is the rate of change positive or negative on this interval? Well, it's positive, then it's negative, right? Where on these, it would just stay one or the other. Okay, so just make sure you're paying attention to which parts you need. Okay, questions? All right, so now I want you to grab your ISN, turn to that first page where you put the title and you wrote some codes on there for me, because I want you to write this down. Oops. Write this down on there, desmos.com/testing/cb-sat-ap/graphic. Because what I noticed, and I noticed it more in my college algebra classes because we really haven't used Desmos in here, maybe a little bit one day, but I had a lot of students that were still going to the testing version that you used in Algebra 1, maybe because that's what's bookmarked or that's what you're used to going to, and that's okay. But the Texas test version, the one that you use in Algebra 1, it has some limitations. And this one is the one that is used for SAT, ACT, PSAT, AP tests, everything. And so I want you to have it written down, because when you go to use Desmos, this is the one I want you using, because it gives you some additional things to be able to do that is important, that's not restricted. And so when you actually go to use this the next time on your computer, make sure you bookmark this so you can get back to it easily, and this will be your go-to Desmos from now on. Okay, that makes sense? And you'll know you're there and you're in the right place if when you get there, it's green. I think the Texas testing version is green also, but it says College Board version right there. Okay, so it's for all the College Board stuff. Okay, but we're going to do example 4, but I'm not going to have you type it in because it's really not necessary to go through all that, because we can just talk about it with me having it typed in. But example 4 says, whoop, let me get back over there. Here we go. All right, for t being between 0 and 3, the number of cars in the parking lot at time t hours can be modeled by this function right here. Based on this model, at what time t does the number of cars in the parking lot change from increasing to decreasing? Okay, so this would be a calculator question, has a little calculator there for you, kind of know that on your assignments as well. And so I typed it in, right? I already have it typed in, so it wouldn't take us forever. And notice I did capital C of t just like it says on there, and I used t's instead of x's just like it says on there, because if I need to do other stuff with it, it makes everything easier, all right? Now, am I interested in this entire graph? No. What part am I interested in? 0 to 3. Definitely not interested in the negative, because that's like negative hours. So I could come over here and change my my x-axis and go to 0 to 3, but that's not necessary. You know, I can zoom in or just at least know what I'm looking at here. But I want to know where the number of cars changes from increasing to decreasing. Now you have to pay attention on these. Is this graph the graph that represents the number of cars, or does it represent the rate of change of the number of cars? What does that say? Says the number of cars in the parking lot at time t hours can be modeled by this function. So C of t is the number of cars in the parking lot. It's possible that we have a question like this and it says the rate of change of the number of cars is modeled by this, and then y'all usually do everything completely wrong because you didn't actually read the question. So Pay attention to what we have. This is actually the number of cars. And then what I'm looking for is what time t, and I'm looking for number of cars. So it's pretty straightforward, right? I don't have to really analyze the graph, but you got to analyze the question to make sure you know what to do once you get there, okay? So what I'm interested in is between 0 to 3. I want to know where it changes from increasing to decreasing. So I would need to kind of zoom a little bit. And y'all have no idea how nice it is because we haven't used those Inspire calculators, because the calculators we were using in here are ones that most of y'all probably never even touched before. And Desmos does all the same things. It's not like it does more, but you don't have to click all those freaking buttons. So all I'm looking for, here's my function. We're increasing and then we're decreasing, right? So basically I'm looking for the relative maximum. I can just touch that point right there and I get this ordered pair. Am I interested in the input value or the output value? What am I looking for? What does it literally say? What does it ask me for? The time. Is the time the input or the output? The time is the input, C of t. Number of cars based on the time. I put in the time, it tells me the number of cars. So I get two numbers here, and if this was a multiple choice question, both of those would definitely be options, but I'm looking for the input. I'm looking for the 2 number there. Okay, does that make sense? So we also have to know what we're getting off the graph. Just because it's easy to touch things doesn't mean, it's easy to answer. So here's what we're going to say. We're going to say the number of cars. I'm not even going to say in the parking lot, and that's okay. The number of cars changes from increasing to decreasing at, and how many decimal places do I write down? 5, okay? And like I said, as we go along, I'll explain to you more why the 5 is important. 2.44564. And no rounding. You just write the first 5 you see and you stop. Why do we not round? Because some of y'all don't know how to, and I ain't got time for that. And college won't take either one. What are my units here? Hours, very good. Because it says time t hours, so my units are hours. Good job. Questions about that? I feel like y'all are well versed enough that you could actually type that in and figure it out as long as we know what to look at. I'm not worried about your calculator skills. Any questions at all? All right, flip it over. All right, so we got a lot of stuff going on that we're going to ask about on this graph. So this guy's name is G also. We're going to identify these characteristics, but we're going to start with some things that are not even listed. Let's see. I want to know, when is G positive? Okay, so we're going to write the intervals for when G is positive. On the graph, how do I know where G is positive? It's above the 0. It's above the x-axis. So G is positive here and here, right? So for this first interval, where do we start? Where's? I know it's going up, but isn't it also going out? Yeah, it's negative infinity, right? It's going to start way out here and keep going. Negative infinity, we never include the infinities, all the way to negative 5. Do I include the negative 5? No, because what's the value of the function at negative 5? 0, and this is 0 is not positive, okay? Then I have another interval, so I start back over at, is that 3? And I'm going to go to infinity. Do I include either one of those? No. Okay, we good on that? So now we're going to look at where is G negative. Well, that's when it's below here. So I would start here at negative 5. Is it negative from negative 5 to 3? No, because I cannot include these 3 points because those points are 0. So I have to go from negative 5 to negative 2. And then basically I'm just skipping over negative 2. So I start back at negative 2 and just leave him out and go all the way to 3. What questions do you have? We all good? Anything? Yes, sir. I'm leaving it out. That's why it's open. So since it's open, I get to use everything up to -2, but not -2. And then I get to jump right over him and go right on the other side to like -2 point infinite number of zeros and a 1, right? Because I got to leave him out because at -2 it's 0. Does that make sense? Great, good question. Anything else? Thank you for asking. All righty. So now the next one asks me for my domain, for my input values here. All real numbers, okay? That's a true statement, and that's we say that a lot, and that's good, but we got to write it as interval notation, so that's -infinity to infinity. Is my range all real numbers? No. Where does my range start? Down here? There's no arrows pointing down anywhere, right? So this is the smallest y value I've got. That's a -9. I know it's small for you to count. I'll just tell you. It's as long as you know it's right there, it's -9. And then I'm going to go all the way to infinity. I do not write infinity to -9. That makes absolutely no sense. You always go left to right, bottom to top, least to greatest. So I'm going from -9 to positive infinity. Think about a number line. Never include infinities. Do I include -9 here? Is -9 a y value on my graph? Yes. And so then I include it. It's a bracket. Okay. Everybody good with that? All right. So intervals where g of x increases. All right, so this looks decreasing to me, then I think we're increasing, decreasing, increasing here, right? So do I start at -5 here? Where do I start? It's the x value, right? Do I care about the y values? The only time I care about the y value is the range. Everything else I'm looking at, my y's are increasing, but I write about x. It goes from -4 to -2. -4 to -2. And I don't include either one of them. Then I start back over at, is that 1? And I go from 1 to infinity. Now, as a little side note here, there are some things we do like increasing and decreasing where I'm telling you open parentheses, and I'm actually going to count it wrong if you put closed. However, when you go to calculus next year, depending on who your professor, your teacher is, they may tell you to do it closed, they may tell you to do it open. This is one of those things where it's sort of the preference of the teacher. I'll tell you why this is my preference for y'all. There's a lot of hard, fast decisions in math, like it is this and it is this universally. This is one of the things that you could argue either way, all right? And I choose to do the open. First of all, I think most of the time that makes more sense. Sometimes mathematically, I could kind of go either way, really. But I think it's simpler for you. So, because we keep most everything is open, and then we only worry about the few times that some things are closed. And if you have it closed and I count it wrong and you say, well, you just told me it could be either one. Well, my guess is you didn't put closed because you're going to have an intelligent argument with me about why it should be closed, is because you don't really know what you're doing. So it's open. Just trust me, it's going to make everything easier. But I want to say that to you. So if next year, in calculus and somebody's saying, well, it should be closed, you're like, that's not what I'm not wrong. They're not wrong. It is what it is. College World will take either one. So. All right, anyway, decreases then. So if we don't have anything constant, if we know our increasing, then really the decreasing should just fill in the gaps, right? So I'm starting at -infinity and going to -4. No, that's a negative, yeah, -4, sorry. And then I'm starting back over at -2 and going to 1. Kind of fills in the gaps for the increases one. Were you raising your hand? Okay. Okay, that's okay. Good. Also, I wanted to say, sometimes I say any questions or you have your hand raised, it's possible that I ask that and I really am paying attention, but then I might look right at you or kind of through you and you're sitting there like this and you're like, what the heck? Holler at me if I'm not paying attention. Even if it looked like I looked right at you. I'm not trying to be rude. I'm just, I don't know. Sometimes in a daze, I guess. All right. So now relative maximum. How many relative maximums do I have? 1. I have a relative maximum right here, right? And so that is where? -2. Okay, so it is at ooh, y'all can't read that. X equals -2. Relative minimums, how many do we have? 2. I got 1 right here, 1 right here. So those are at X equals -4 and 1. And notice, oh, I don't know why I put a parenthesis, sorry. That's where you're changing from increasing to decreasing. Those are your relative max and mins. All right, absolute maximum, what do we think? None, because this keeps on going, right? So we have none. What about absolute minimums? Good, -9 at X equals 1. All right, so for maximum we have none. And then absolute minimum, we're going to say it is -9 at X equals 1. Okay. Everybody good with that? All right, then our points of inflection. I actually put the dots on there so we weren't guessing. So I've got, this is concave up. Then we change to concave down. We have 1 right there. We're concave down, then change to concave up. We got 1 right there. So they happen at, is that -3 and -1? X equals -3 and -1. We good? All right, you write your intervals for concavity and make sure you agree with your neighbor. Help your neighbor if they're not sure. Okay? Yeah, sure? No, okay. All right, who wants to give me the concave up intervals? Anybody? All right, I can use my handy dandy spinner. That's fine. Let me get it. Oh, man. Ay. Y'all are making everything difficult here. There we go. Oh, my goodness. All right, never mind. This is what doesn't want to cooperate. Ugh. I spend all day doing this. What the heck? All right, whatever. Somebody tell me, where do we start? Thank you. I was hoping somebody else, because I appreciate you, but you're the only one that will talk to me. So -infinity to what? -3, okay. And then what? -1 to infinity, very good. And then look, this is our points of inflection happen here and here. So your concave down really just has to fill in the middle, right? So that's just going to go from -3 to -1. Okay. What questions do we have? Anything? We good? You got this? Yes? All righty. Don't forget that you have a quiz tomorrow over 1-3.